Alright, slight mishap with the iPad. We're going to have to start over on number 7. So we've got number 7. And want 1 and 2. In order to do this, I'm going to go straight to my big triangles. I'm going to make this big triangle equal to this big triangle. The way I'm going to do that, I know that 3 and 4 are congruent because they're vertical angles. I know that 5 and 6 are congruent. That's given. I'm going to use the angle addition postulate to make them equal to each other. And then I have angle, side, angle. On my big triangles, I can rip off 1 and 2 using that method. You know what? We're just going to switch over at that point to what I had before my camera switched off. So we're going to make 3 and 4 congruent, 5 and 6 congruent. We need to use the angle addition postulate. We need an equation. So I'm going to switch them both to equality using the definition of congruence. Angle addition postulate at that time, I'm going to call out my big angles. JHL is made up of its pieces. NHL is made up of its pieces. And then I'm going to substitute in. I know that 3 is equal to 4, so I can replace 3 with 4. I know 5 is equal to 6, so I can replace 5 with 6. And then at this point, I have NHL, JHL equal to the same thing. I can say that angle NHL is equal to the measure of angle NHL is equal to the measure of angle JHL, again, by substitution. At this point, we're going to switch again over to the old pad, paper. Cha-cha. And now that I've got those two equal, I'm going to switch them back over to congruent. So angle NHL is going to be congruent to angle JHL. We're using the fact that they are equal to make them congruent, so definition of equality there. At this point, I'm going to take and just call out the rest of my stuff. They share HL. That's going to be reflexive. I was about to put share, and it does not work. And then we'll call this angle 7 and angle 8. Angle 7 is congruent to angle 8. That is also given. And now I can grab my two big triangles. I've got JHL is going to be congruent to NHL by angle side angle. And then I can rip off angle 1 and angle 2 with CPCTC. Now, angle 8. There's probably a better way to do angle 8 than the way I'm about to show you, but I could not think of another way. What I'm going to do is take these two little triangles. They are given right now as congruent. Then I'm going to rip off this side, and at that point I'm going to do the exact same process. We'll call this angle 3, angle 4, angle 5, and angle 6. I know 5 and 6 are congruent. I know 6 is, we don't have to use angle addition postulate though. Angle 6 is congruent to angle 3. Angle 5 is congruent to angle 4. I'm going to use the transitive property. 3 and 4 are going to be congruent. And then once I get that, I can switch them all, do a little angle addition postulate. I'm going to have to do that rough. Do a little angle addition postulate, a little substitution, and I'm going to make those two big angles equal to each other, and that's going to give me angle side angle. Make the big ones congruent, and then it's on from there. So let's get it. Let's get it. We're going to go get our little triangles congruent first. So BA is congruent to FG. It's going to be given. Angle A is going to be congruent to angle G. That's also given. Angle 5 is congruent to angle 6. That's also given. And that's going to allow me to get my two little triangles. BAD is congruent to triangle, if I started at BFGD. Angle side angle. Why did I do this line right here? I want AD and GD. So I'm going to call that out. AD, GD, congruent, CPCTC, all of that for a little CPCTC. I assure you that's short because we're about to do a whole bunch to get these two angles. Let's see if we got a little action here. Here we go. Boom. A little bit more action. So I'm going to say that angle 6 is congruent to angle 3. Vertical angle is congruent. I'm going to say that angle 4 is congruent to angle 5. And that's going to be the same. I'm then going to go in and make, do I have to go back? You know what? I don't have to do anything else. So I'm going to switch those both over to measure. The measure of angle 6 is equal to the measure of angle 3. The measure of angle 4 is equal to the measure of angle 5. And that's going to be the definition of congruency. It is the congruency that means they are equal. We are using the definition of congruency. I'm then going to say the measure of angle, big one, CDA, is equal to the measure of angle 3 plus the measure of angle 5. The measure of angle, big one over here, EDG, is equal to the measure of angle 4 plus the measure of angle 6. Those are both going to be the angle addition postulate. And then I've got substitution. If I want 4, I can also use 5. If I want 6, I can also use 3. So I can say the measure of angle CDA is equal to the measure of angle 6, plus the measure of angle 4 by substitution. I'm then going to go through and say that the measure of angle CDA is now equal to the measure of angle EDG, also by substitution because I've got them equal to the same sum. From here, going right along, I've got my big angles equal. I want them congruent, so I can rip the triangles. CDA is going to be congruent to EDG. I'm using the fact that they are equal to make them congruent. So that's going to be the definition of equality. And I actually have all my pieces for the triangle proven. I just got these two angles. I have these two sides right here for the previous triangle. I have these two angles right here. There they are for the previous triangle. So I've got everything that I need. I can call out my two triangles. Triangle CDA is going to be congruent to triangle EDG. Angle side angle, and then I can rip off angle 1 and angle 2. Angle 1 is congruent to angle 2, CP, CT, C. Done. Alright. We'll cut the video here. We'll do these two on their own video, that way we don't run over. Ciao.